Hi guys, I am ZAINALI from Cricket Academy. This tutorial we would be solving a problem related to a projection of point. Now, before solving a problem related to a projection of point, let us recall about the position of the point in different quadrant. We know that whenever a point is resting in the first quadrant, it is said to be resting above the horizontal plane and in front of the vertical plane. Similarly, for the second quadrant, it is said to be resting above the horizontal plane but behind the vertical plane. For the third quadrant, it is said to be resting below the horizontal plane and behind the vertical plane. For the fourth quadrant, it is said to be resting below the horizontal plane and in front of the vertical plane. Now, let us see the question which would be solving today. So this is a problem which we'll be taking into consideration. If we simply read the problem that a point A is 25 mm above the horizontal plane and 30 mm in front of the vertical plane, draw its projection. We come to know that here the position of the point has not been mentioned directly, that whether it is resting in the first quadrant or whether it is resting in the third quadrant. We have to determine the position of the point or the quadrant in which the point would be resting. So our first step for solving any problem related to a projection of the point is to determine the quadrant in which the point would be resting. Then after we have to determine the value of h and the value of d, where h is the distance from the horizontal plane and d is the distance from the vertical plane. If we take the first case into consideration, then it has been mentioned that a point A is 25 mm above the horizontal plane and 30 mm in front of the vertical plane. Above the horizontal plane indicates that the point must be either resting in the first or second quadrant, but 30 mm in front of the vertical plane indicates that a point lies in the first quadrant only. So let us note it down. For the first case, the point is resting in the first quadrant. H is the distance from the horizontal plane which is given as 25 mm. D is the distance from the vertical plane which is given as 30 mm. If we take second case into consideration, then a point B is 20 mm below the horizontal plane. Below the horizontal plane indicates the point must be either lying in the third or fourth quadrant. If we read further, 30 mm behind the vertical plane, it now indicates that a point only lies in the third quadrant only. It doesn't lie in the fourth quadrant. So let us note it down. The point lies on the third quadrant only. H is the distance from the horizontal plane which is given as 20 mm and D is mentioned as 30 mm. For the third case, a point C is in the horizontal plane. In the horizontal plane, it indicates that a point must be lying somewhere here. But 20 mm behind the vertical plane. Behind the vertical plane indicates that a point must be either resting in the second or the third quadrant. Let us note it down. Second or third quadrant. H is the distance from the horizontal plane. Since the point is in the horizontal plane, the distance becomes 0. So let us note it. And here the value of D is given as 20 mm. For the fourth case, a point D is in the vertical plane. Vertical plane indicates that somewhere here it would be resting 40 mm above the horizontal plane. 40 mm above the horizontal plane indicates that the point must be either resting in the first or second quadrant. So let us note it down, first or second quadrant. Now, whenever a point is resting in the vertical plane, then the distance from the vertical plane becomes 0. Hence the value of D becomes 0. Moreover, the value of H has been given as 40 mm. Value of H has been given as 40 mm in this question. If we take fifth case into consideration, then the point E is 15 mm above the horizontal plane. Above the horizontal plane indicates it must be resting either in the first quadrant or in the second quadrant. But 50 mm behind the vertical plane now clearly specifies that the point only lies in the second quadrant only. So let us note it down that a point lies in the second quadrant. The distance from the horizontal plane is mentioned as 15 mm and the distance from the vertical plane is mentioned as 50 mm. For the sixth case, a point F is in both the horizontal plane and the vertical plane. To determine the quadrant, we have to take all the four quadrants one after another in both the horizontal plane and the vertical plane. In the horizontal plane, and in the vertical plane also. For the first quadrant it resembles a reference line xy only. For the second quadrant also, in the horizontal plane and in the vertical plane, a point can only lie along the on the reference line only. For the third quadrant also, in the horizontal plane and in the vertical plane, point lies in the reference line on the reference line only. For the fourth quadrant also, a point lies on the reference line only. Hence, a point F is said to be lying in either of the first, second, third or fourth quadrant. So let us note it down: first, second, third or fourth quadrant. Moreover, it is resting in the horizontal plane, as the value of dh is equals to 0. Moreover, value of d is also equals to 0. This table we will be taking into consideration for constructing the orthographic view for a point resting in the different quadrants. For constructing the orthographic view, we have to initiate by constructing the reference line xy, which is here as follows. Now, before constructing the orthographic view, let us note the certain important points for constructing the front view and top view for different position of point. We know that whenever a point is resting in the first quadrant, front view lies above the top view. For second quadrant, both front and the top view lies above the reference line. For third quadrant, top view lies above the front view, and for the fourth quadrant, both top and the front view lies below the reference line. This reference line is the xy line only. Now, the table which we have constructed from the data given in the question, we would be using that table for constructing the orthographic view. So we have discussed that whenever a point is resting in the first quadrant, then front view lies above the top view. Moreover, distance h is used to mark the front view, while distance d is used to mark the top view. Hence, for the first quadrant, since front view lies above the top view, the distance h should lie above the distance d. Moreover, distance h is above the reference line and distance d is below the reference line. So let us plot it down. Now, as the distance is mentioned as 25 mm, so let us draw the 25 mm projector above and 30 mm projector downward direction. Okay, so this point is given as a dash and this point is given as a. Now we have to carry out dimension along with. So there are two types of dimensioning system. First is aligned system. One can say it is a aligned system in which dimensioning is carried out in such a manner, and another one is unidirectional system where dimensioning is carried out in such a manner. So we will be basically using the aligned system for dimensioning. So let us carry out dimensioning also. This distance is given as 25 mm, so let us plot it 25, and this distance is given as 30 mm, so let us plot it as 30 mm. Now, for the second case, a point is resting in the third quadrant. This indicates that top view lies above the front view. Distance d used to mark the top view is now above the reference line and distance h is below the reference line. So let us note that 30 mm is above the reference line while 20 mm is below the reference line. This distance is given as 30 mm and this distance is given as 20 mm. Now, here the top view lies above the front view. This is our top view and this is our front view. These are projectors which should be drawn with the help of a faint line only. For the third case, point resting in the second quadrant as well as third quadrant. For the second quadrant, both front and the top view must lie above the reference line, but since the distance h is 0, the point c dash lies on the reference line only. So now, for the third quadrant, we know that top view lies above the front view. Since it is a front view, the top view must lie above the front view, hence it must lie above the reference line only. Hence our condition for both second quadrant as well as third quadrant has been satisfied. So the distance D is given as 20 mm, which we will be plotting it. So the distance is given as 20 mm. So let us plot it down. It as a 20 mm, and this point is given as C, which is our top view only. Now for the fourth case, a point is resting in the first quadrant or a second quadrant. Distance h is 40 mm and distance D is 0 mm. So whenever distance D is 0 mm, this indicates that the top view is on the reference line only. So let us plot our top view first. So this point represents our top view as point D. Now, since in the first quadrant front view lies above the top view, hence the front view must lie above the reference line only. Moreover, for the second quadrant, both the top and the front view lies above the reference line only. Hence our condition is going to satisfy. So let us plot the distance h above the reference line. When as here, so this distance is given as 40 mm. This point is mentioned as D dash. Now for the fifth case, a point is resting in the second quadrant. This indicates that both front and the top view lies above the reference line only, so that the distance h and the D has been plotted above the reference line only. So let us plot it down. Our front view lies at a distance of 15 mm, and our top view lies at a distance of 50 mm. So here somewhat it must be resting. Now let us plot it down. This point is our top view distance, so it is our E point, and this is our E dash point. Let us dimension it also. This distance is given as 15 mm, and this distance is to be given as which distance? This distance should be given as 50 mm. Now for the sixth case, a point is resting in either first, second, third or fourth quadrant. Value of h and D is mentioned as 0 mm. So it indicates that both the front and the top view lies on the reference line only. So let us plot the point F and F dash on the reference line only. It doesn't mean that if we plot the point F dash above the reference line or below the reference line, as the distance from the reference line is 0 only. So guys, this is all regarding solving the problem and different types of dimensioning system. Hope you that you like this video. Don't forget to subscribe my channel.